Hello class, welcome to the next video of matrices. Previously we had seen about the determinant of matrices. Now in today's video we are going to see the cofactors of an element and adjoint of a matrix. Okay, so now let's start with the cofactor of an element. So cofactor of an element is a part of two things. One is a sign and second is a determinant. Okay, now sign will be as you can see in this, sign will be like this. Okay, that means starting with plus, minus, plus, then after plus next sign will be minus, alternate sign, minus, then plus, then minus, after minus next will be plus, then minus, then plus. For this is for 3 by 3 matrix. Okay, so sign will be alternate for 3 by 3 matrix. Similarly for 2 by 2 matrix. So for 2 by 2 matrix, sign will be, for 2 by 2 matrix sign will be plus, then minus, then minus, then plus, alternate sign. This is for 2 by 2 matrix. Okay, so 3 by 3 and 2 by 2 matrix. So first part of finding the cofactor is finding the sign of an element. So sign will be plus, minus, minus, plus, alternate sign. Okay, so after this sign, next is finding the determinant value. Now in this you have to find the cofactor of each element. Okay, of each element of matrix. So first let us start with the cofactor of A1. Okay, to find the cofactor of A1, first we have to take the sign. So for A1 sign is what? Sign is plus, right? For A1 sign is plus. Then same concept, delete the position of A1. So deleting the position of A1 means first row, first column deleted, and find the determinant of remaining element. So remaining elements are B2, B3, C2, C3. So determinant of B2, B3 and C2, C3. Okay, so this determinant along with sign represent the cofactor of A1. Okay, similarly we have to find cofactor of all the elements, like find the cofactor of B2. So for B2 cofactor will be cofactor of B2 will be, first we have to take the sign. So for B2 sign is what? Sign is plus. Okay, then delete the position of B2. Now what is the position of B2? Position of B2 is second row, second column, right? After deleting second row, second column, we are getting determinant of A1, A3, C1, C3, right? Then find the determinant of A1, A3, C1, C3. Okay, so similarly we have to find the determinant of all elements of matrix A. Okay, one more, suppose we have to find determinant of B3. Now how will you find the determinant of B3? So B3, first we have to find the sign. Sign is what? For B3 sign is minus, so minus. Then delete the position of B3. What is the position of B3? Position of B3 is third row, second column. So after deleting third row, second column, elements are A1, A2, C1, C2, right? So similarly you have to find cofactors of all the elements. Okay, now one more, suppose we have to find the cofactor of C3. To find the cofactor of C3, first we have to write the sign of C3. So sign of C3 is plus, right? So plus, then delete position of C3. What is the position of C3? Position of C3 is third row, third column. After deleting third row, third column, remaining elements are A1, A2, B1, B2. So find the determinant of this numbers, these elements. Okay. Now this is the concept of cofactor. So to find adjoint of a matrix, we have to find the cofactor of each and every element of matrix A. Okay, that means what you have to do, you have to find the cofactor for A1, then cofactor for A2, then cofactor of A3. Similarly, you have to find cofactor for B1, B2 and B3. Okay, then cofactors of C1, C2, C3. You have to find cofactors of all the elements of matrix A. Okay, and before finding the cofactors, just write down the sign for cofactors. So sign, alternate sign, okay, starting with plus, then minus, then plus, then again minus, plus, minus, plus, minus, plus. Okay, now after finding cofactor, next concept is adjoint. Okay, to find adjoint, steps are first step is find cofactors for each element of a matrix. First you have to find cofactors of each element of a matrix. Then what you have to do, you have to write down the cofactor matrix, and this cofactor matrix, suppose we are going to denote this cofactor matrix by P. So in second step we have to write the matrix P. Matrix P is a matrix of cofactors. In third step, what we have to do, we have to find the adjoint matrix, which is a transpose of a cofactor matrix. So in third step, what we are going to do, we are simply finding the transpose of P. Okay, so class, 3 steps. First step is finding the cofactors for each element of a matrix. Second step, writing down matrix of cofactors, right? That means P. And in third step, we are finding the transpose of cofactor matrix. That means P dash. Okay, so 3 steps. So if the question is find the adjoint of a matrix, then we have to do the simply 3 steps. In first step, we have to find the cofactors, right? Cofactor कैसे find करना है, that we had already seen. For cofactor, we have to, first we have to find the sign, right? For cofactor, first we have to find the sign, and then deleting that element, position of that element, then find the determinant of remaining numbers or remaining elements. So first step to find the adjoint, first step is finding the cofactors of each element of a matrix. In second step, what we are doing, in second step we are writing simply cofactor matrix. That means we are writing P. And in third step we are taking transpose of P. That means we are taking transpose of cofactor matrix. Okay, so after this, after finding adjoint of a matrix, So in mathematically we can show that adjoint of a matrix A is transpose of C. In our case we are denoting C. C for cofactor matrix. So we are denoting that cofactor matrix as P. So transpose of P, right? And transpose of P is first take the sign, right? And then delete the position for A11 position. After deleting the position, we are getting elements A22, A23, then A32 and A33. Okay. So in mathematically we can write adjoint of a matrix in this way. Adjoint of a matrix is what? Adjoint of a matrix is a transpose of cofactor matrix, and cofactor matrix is a nothing but sign plus determinant of after deleting the position of number. Okay, then see one more example for finding the adjoint of A. A is a matrix of 6, 5, 2, 1. Okay. Now what we have to do? We have for finding adjoint of a matrix, first we have to find the cofactors of all the elements of matrix A. Now starting with the first element of A is 6. Now cofactor of matrix, cofactor of element 6, that will be, first write down the sign. So sign 2 by 2 है ना, so sign will be plus, then minus and then plus, right? So you take sign from this matrix, right? So for finding cofactor of a matrix C, cofactor of element 6, take the sign from this matrix. So sign is plus, then delete the position of 6. What is the position of 6? First row, first column. After deleting first row, first column, remaining number is 1. Okay. Similarly, now take the cofactor of element 5. Now for 5, sign is minus. So minus. Then delete the position of 5. Position of 5 is first row, second column. After deleting first row, second column, remaining number is 2. So minus 2. Okay. Similarly, now take the third element. Third element is 2. So cofactor of element 2, delete, first take the sign. Sign is minus. So minus. Now delete the position of 2. What is the position of 2? Second row, first column. Okay. So delete second row, first column. After deleting second row, first column, the remaining number is 1. So second row, first column. So the remaining number is 5. So minus 5. Now take the last element of A matrix. So cofactor of element 1. Delete the position of 1. Position of 1 is second row, second column. Okay. So the number is 6. Sign is plus. So plus 6. Okay. So first step to find the adjoint is finding the cofactor of each element of matrix A. Okay. After finding cofactors of each element of matrix A, write down the cofactor matrix. Now cofactor matrix, for 6 cofactor is 1. So 1. For 5 cofactor is minus 2. So minus 2. Then in place of 2, we are writing the cofactor of 2. Cofactor of 2 is minus 5. In place of 1, we are going to write the cofactor of element 1, and cofactor is 6. Okay. So write down the cofactor matrix. After writing cofactor matrix, then adjoint of a matrix A is simply transpose of P matrix, and transpose of P matrix means interchanging row in column, right? So 1 minus 2 will be first column, first row will be first column. So 1 minus 2, second row will be second column, minus 5, 6. Okay. So this is the example of finding adjoint of a matrix A. Let us see one more example. So again, question is find the adjoint of a matrix A. A is given as this matrix. Okay. So first what we have to do? First we have to write the sign. Right? Define the sign. So plus minus plus, then minus plus minus, and minus plus minus plus. Okay. So after writing or after defining this sign, next what you have to do? You have to find the cofactors. So for cofactors, what we have to do? We have to first take the sign and then deleting the position of that number, finding the determinant of remaining numbers. So for C11, that means cofactor of first element, cofactor of 1. Cofactor of 1 will be, take the sign is plus, then delete the position of 1. Position of 1 means first row, first column. After deleting first row, first column, remaining numbers are 0, 2, 1, minus 1. Okay, and take the determinant of this number. So determinant is minus 2. Okay, then for second element is 3. For 3, take the sign is minus. Okay, and delete the position of 3. Position of 3 is first row, second column. So delete first row, second column. After deleting first row, second column, we get the numbers 3, 2, 1, minus 1. Right? Then find the determinant of 3, 2, 1, minus 1, which is 5. Okay. So similarly, you have to find the cofactors of each element. Okay. See here. Find cofactor of each element. First element, then second element, then third element. Okay. C11, this is for 1. This is for 3, cofactor of 3. Then this one is for cofactor of 2. C21 means cofactor of minus 1. C22 means cofactor of 0. C23 means cofactor of 2. Okay. C31 means cofactor of 3. C32 means cofactor of 1. C33 means cofactor of minus 1. Okay. So find all the cofactors. Okay. After finding cofactors, then write the cofactor matrix. Okay. Write the cofactor matrix, and then adjoint of a matrix is nothing but transpose of cofactor matrix. So that means P dash. Okay. See one more example. Again question is find the adjoint of a matrix A. Okay. So if A is a matrix of 1, 0, minus 1, 3, 4, 5, 0, minus 6, minus 7, then finding the adjoint of a matrix A. So first we have to write the sign. Write the sign. Okay. Then find the cofactor of each element of a matrix. Cofactor of each element of a matrix will be first we have to take the sign, right? We have to take the sign. C11 means cofactor of first number means 1. So first we have to take the sign. Sign for 1 is plus, right? Then after deleting the position of 1, we get the determinant of 4, 5, minus 6, minus 7, right? So that cofactor for element 1 is 2. Okay. Now cofactor for second element is 0. So for 0 we are finding C12. C12 for 0 sign is minus. Okay, then delete the position of 0. Position of 0 means first row, second column, and then find the determinant of remaining numbers. So remaining numbers are 3, 0, 5, minus 7. Okay, then third number is minus 1. So cofactor for minus 1, take the sign is plus. Okay, then delete the position of minus 1 means first row, third column. So that will be C13. Okay, similarly for second row, C21, C22, C23. Similarly for third row, C31, C32, C33. So find all the cofactors. Okay, find cofactors for all the elements. After finding cofactors, then write the cofactor matrix, and then adjoint will be transpose of cofactor matrix. Okay. So these are the some exercise questions which you have to solve. Answer is already given. Okay, I have already given the answer. So just find the adjoint of A matrix. Okay, and adjoint will be this. So you can check your answer. After finding adjoint, you can check your answer. Answer is given. So with this, I am finding this video. In next video we can see inverse. Okay, inverse of a matrix. So thank you students.